The most important application of partial differentiation is finding Jacobian of given functions. It helps you while evaluating integrals to change one variable to another variable to evaluate integral. We will discuss that one in while evaluating multiple integrals. There I will discuss very clearly in the next unit. Here, that is most important application of Jacobian. Jacobian helps you to change integral from one variable to another variable and to evaluate. We use Jacobian there. So what is actual Jacobian? So first I am explaining Jacobian for two variables like this. If u is function of xy, v is function of xy, then Jacobian of uv with respect to xy is denoted like this. Dou of uv by dou of x comma y, or like this, dou of uv by dou of uv by dou of x comma y, uv by x comma y, or we can represent this one with j. What is this actually? Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. This is called, this determinant value is called Jacobian of uv with respect to xy. This one simply can be written like this. U suffix x is dou u by dou x, uy, vx, vy. Clear ma? Similarly, if we have three variables like this, u is function of x, y, z, three variables. This is two variables case. V is function of x, y, z. W is function of x, y, z. Then Jacobian of UVW with respect to x, y, z. Jacobian of UVW with respect to x, y, z is represented like this one. Dou of UVW by dou of x, y, z equal to, similarly, like two variables, dou u by dou x, dou u by dou y, dou u by dou z. V with respect to x, y, z, dou v by dou x, dou v by dou y, dou v by dou z. W, dou w by dou x, dou w by dou y, dou w by dou z. This can be written very simply like this one. Ux, uy, uz, vx, vy, vz, wx, wy, wz. So here one can easily evaluate Jacobian of given function using these two formulas. For example, u is like this one. U is x square minus 2y. V is x plus y plus z. W is x minus 2y plus 3z. Then we need to find dou of UVW by dou of x, y, z. So three variables here. Here we need to differentiate three variables with respect to three variables. This formula we need to use. For that, what we are doing, directly I am evaluating dou of UVW by dou of x, y, z equal to ux, uy, uz, vx, vy, vz, wx, wy, wz. Ux means, I said this one only, uy means this one. Ux means differentiate u partially with respect to x. What you will get? If you differentiate partially u with respect to x, differentiate x terms only, don't differentiate other. So differentiation of x square is 2x. Differentiate u with respect to y, differentiate y. Differentiation of y is 1, you don't have y here. So this becomes 0. What you will get? Minus 2. Now differentiate u with respect to z. Do you have z in the u? No. So Keep that one as constant, that becomes 0. This is minus 2. Next, differentiate v with respect to x. Differentiation of x 1. Remaining 2 becomes constant. Differentiation of y is 1. Remaining 2 becomes constant. Differentiation of z is 1. Now, differentiate this one with respect to x, y, z. Differentiation of x is 1. Differentiation of y is 1, you will have minus 2. Differentiation of z is 1, you will have 3 only. Now we need to find determinant of this one. So, using det method, plus minus plus. 2x into 2x corresponding column row eliminated. Now, AD minus BC technique. 3 1 are 3. Minus into minus plus 2. Minus into minus plus 2. Corresponding column row eliminated. Second column, first row. 1 3 are 3. 1 1 are 1. So what you will get, here 5 you will get. If you multiply this one with 5, 3 plus 2 5. 5 2 are 10. 10x plus 3 minus 1 is 2. 2 2 are 4. This is Jacobian value. Jacobian of given u, v, w with respect to x, y, z. One can evaluate easily like this one. Are you clear? So now we are going to evaluate Jacobian of x, y with respect to u, v. X, y are given like this one. So now to find Jacobian of x, y with respect to u, v, I am writing x, given x and y very clearly. X equal to u plus uv and y equal to multiply with v into 1 v plus v into u, vu or uv. Now I am going to find Jacobian of xy with respect to uv. Dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v. So Jacobian value we are going to evaluate. Dou x by dou u, dou x by dou u. Dou u means you need to differentiate x with respect to u. So differentiate u terms only, don't differentiate v. So differentiation of u is 1, then what happens? 1 plus v you will get. Differentiation of u1, differentiation of u1. Differentiate x with respect to v. In the first term you don't have v. That's why differentiation of this term becomes 0. Differentiation of v is 1. What is left over? U. Next, dou y by dou u. Differentiate this one with respect to u. In the first term you don't have u. So treat that one as constant. Differentiation of constant is 0. So differentiation of u is 1. What is remaining? V. Next, differentiate y with respect to v. If you differentiate y with respect to v, differentiation of v is 1. Differentiation of v is 1. 1 plus u. Now, AD minus BC technique. AD minus BC. What you will get? 1 plus v into 1 plus u minus u into v. Multiply, what you will get? 1 into 1, 1. 1 into u, plus v into 1, v. Plus v into u, vu. Minus uv. Plus vu minus uv. Get cancelled. What is remaining? That's what we need to prove. 1 plus u plus v. That's what we need to prove also. Like that, one can easily find out the Jacobian of uv of two functions. In the similar manner, we are going to discuss one more problem. If u equal to x square minus y square and v equal to 2xy and x is r cos theta, y is r sin theta, then prove that dou of uv by dou of r comma theta equal to 4r cube. This one we need to prove. Next problem. Similar like previous one only. We are going to evaluate next evaluation. First, in the given, I am going to write in the place of x r cos theta, in the place of y r sin theta in this. U equal to x square minus y square. What is x? r cos theta. Right in the place of x r cos theta, r square cos square theta minus r square sin square theta. Y is r sin theta. Take r square common ma. If you take r square common, cos square theta minus sin square theta. What is cos square theta minus sin square theta? Cos 2 theta. That means r square cos 2 theta. Similarly, find out v ma. V equal to 2xy. Right in the place of x r cos theta, in the place of y r sin theta. 2 into r cos theta r sin theta. That equal to r square. R into r square ma. 2 cos theta sin theta. 2 cos theta sin theta is 2 sin 2 theta. 2 cos theta sin theta sin 2 theta r square sin 2 theta you will get. Now uv is r square cos 2 theta. V is r square sin 2 theta. R square cos 2 theta, r square sin 2 theta. Now find out this one. Which one? Dou of uv by dou of r comma theta. So dou of uv by dou of r comma theta we need to find. For that, you know the formula. Dou u by dou r, dou u by dou theta. Dou v by dou r, dou v by dou theta. Now we are going to evaluate that value ma. So here dou u by dou r means differentiate u with respect to r. If we differentiate u with respect to r, differentiate r terms only. Differentiation of r square to r cos 2 theta you can write as it is. And differentiate u with respect to theta. Differentiation of cos theta minus sin theta. Differentiation of cos theta minus sin theta. Again you will have one more two that will come as a coefficient. Differentiation of cos 2 theta minus 2 sin 2 theta. That means minus 2r square sin 2 theta. Like that you need to differentiate v with respect to r ma. V with respect to r. Differentiation of r square to r. 2r sin 2 theta. Differentiation of sin 2 theta 2 cos 2 theta. That means r square 2 cos 2 theta. Differentiation of sin 2 theta 2 cos 2 theta. Now AD minus BC technique ma. 2 into 2 4 r square into r cube. Cos 2 theta into cos 2 theta cos square 2 theta. In between you will have minus and here one more minus. Minus into minus plus 4r cube sin 2 theta into sin 2 theta sin square 2 theta. Now take 4r cube common ma. You take 4r cube common. Cos square 2 theta plus sin square 2 theta. What is cos square 2 theta plus sin square 2 theta? 1. So finally this value is 1. This one we need to prove. Are you clear ma? Any doubts you can express. So next one ma, on Jacobian only. To find Jacobian of xyz with respect to uvw. To find Jacobian of xyz with respect to uvw, x should be in terms of uvw, y should be in terms of uvw, z value should be in terms of uvw. Here we are having only z in terms of uvw. Why we don't have in terms of uvw? That's why what I am doing. So from this, y plus z is uv. What is y ma? What is y? uv minus z. What is z? uvw. uv minus uvw. In the similar way, from this, x equal to u minus of y plus z, right? From this, send y plus z to that side. What is y plus z? uv. X equal to u minus uv. Y is this one, z is given like uvw. I converted given functions like this one. Now I am going to evaluate dou of xyz by dou of uvw value. For that, dou x by dou u, dou x by dou v dou x by dou w, dou y by dou u, dou y by dou v, dou y by dou w, dou w by dou u, dou w by dou v, z, right, sorry, dou z by dou u, dou z by dou v, dou z by dou w, dou z with respect to u, v, w. Now what you will get, ma? Dou x by dou u. Differentiate x with respect to u. Differentiation of u is 1, 1, 1. What you will get? 1 minus v. Differentiation of x with respect to v. You don't have v here. This becomes 0. Differentiation of v1. What you will have? Minus u. Differentiate x with respect to w. Do you have w in x? No. Then what happens? We will treat that one as constant. Differentiation of constant is 0. Next, differentiate y with respect to u. So wherever you will have u, there you can keep 1 because differentiation of u is 1. So here 1, here 1. What you will get? V minus vw. Differentiate y with respect to v. Here also like that only. Wherever you will have v, there write 1, 1. U minus uw. Differentiation of y with respect to w. You don't have w in the first term. That's why differentiation of w is 1. You will get minus uv. Now differentiate z with respect to u. Differentiation of z with respect to u, vw. With respect to v, v becomes 1. Remaining 2 terms, uw. Differentiation of w is 1. Keep uv constant like that. So differentiation of u1, differentiation of v1, differentiation of w1. Now using determinant technique, cofactor signs, plus minus plus, evaluate this one. 1 minus v into 1 minus v corresponding column row eliminated. Multiply these two. This one into this one minus this one into this one. Multiply these two. U into u. U square v. Again u into u. U square v w you will get as it is. This is AD minus BC minus here also. Already you are having minus, minus into minus plus, u into u, u square, remaining vw as it is you will get. So this is 1 minus v into minus plus, u into plus u into u corresponding column row. U corresponding column row is eliminated. That means second column first row. Multiply this one with this. U into v, ub into v. uv square, okay, uv into vw minus uv square w. This is AD minus BC minus here also one more minus plus uv into vw, uv square w. So what happens, ma? U square vw, u square vw get cancelled. Here uv square w, uv square w. Now multiply with this one. 1 into u square v minus v into v square, u square v square plus multiply this one with this u into u square v square. These two get cancelled. So finally what you are having? U square v you are having. U square v you are having. So next I am going to evaluate next problem on Jacobian only. In that I am going to show Jacobian and its inverse Jacobian product is 1. For that I am taking this problem. If x equal to r cos theta, y equal to r sin theta, then show that dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y is 1. That one we need to prove. So first I am taking this one directly more because x r cos theta, y r sin theta. We can evaluate that one directly. That is dou of x comma y by dou of r comma theta. You can evaluate directly like this. Dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. This is formula of Jacobian. Now differentiate x with respect to r. Differentiation of r1. Differentiation of r1. What is remaining? Cos theta. Now differentiate x with respect to theta. Differentiation of cos theta minus sin theta. You can keep r constant. Differentiation of cos minus sin. That means minus r sin theta. Next. Differentiate y with respect to r. Differentiation of r is 1. So what remaining? Sin theta. Differentiation of sin theta, cos theta, that is r cos theta. Now AD minus BC, multiply this one into this one. R into cos theta cos square theta, plus r into sin theta, sin square theta. If you take r common, what happens? Cos square theta plus sin square theta you will get. If you take r common, then cos square theta plus sin square theta is 1. R is dou of x comma y by dou of r comma theta value. Okay ma. Now we need to find its inverse. That means we need to differentiate r with respect to x, r with respect to y, theta with respect to x, theta with respect to y. To differentiate like that, we need to rearrange the given functions, r in terms of xy, theta in terms of xy. We all know that x is r cos theta, y is r sin theta. So if you square and add, that means I am going to find reverse dou of r comma theta by dou of x comma y. Reverse. For that, what I am doing? I am squaring and adding x and y. What is x? R cos theta. R square cos square theta. Here also we will get one more r square. I am taking r square common. Sin square theta. That means cos square theta sin square theta is 1. What is r square ma? R square equal to x square plus y square. Finally r is root of x square plus y square r. Similarly, if you divide y and x, y by x equal to r sin theta by r cos theta. R get cancelled ma. That means r cancel, sin by cos tan. From this, what is theta ma? If you send tan to that side, tan inverse you will get. Tan inverse y by x. If you send tan to this side, tan inverse. So theta is tan inverse y by x. R is this one. Clear ma? So now I am going to find its inverse Jacobian, this one. Dou of r comma theta by dou of x comma y equal to dou r by dou x, dou r by dou y, dou theta by dou x, dou theta by dou y. So we know what is the answer we have to get. To show 1, because this one is r, here we need to get 1 by r. 1 by r means 1 by root x square plus y square we need to get. For that I am differentiating ma. Differentiation of r with respect to x. Differentiate this one with respect to x. Differentiation of root x 1 by 2 root x. 1 by 2 root x square plus y square. Again differentiate x square, you will get 2x. Similarly differentiate r with respect to y. 1 by 2 root x square plus y square. Again differentiation of y with respect to y, 2y. Okay, now differentiate tan inverse x. Differentiation of tan inverse x is 1 by 1 plus x square. So tan inverse y by x, this one is x, you need to square y square by x square, and in numerator differentiate y by x keeping y constant. If you keep y constant, you will have 1 by x. Differentiation of 1 by x minus 1 by x square. That's why in numerator you will get minus y by x square. Similarly, differentiate with respect to y, there also you will get 1 by 1 plus y square by x square you will get, and keeping 1 by x constant, differentiate y. Differentiation of y 1, that 1 by x constant will be there. Here 2 get cancelled. That will be same, x by root of x square plus y square, y by root of x square plus y square. Now, this one, if you take x square LCM, x square get cancelled. What is remaining? Minus y by x square plus y square. Similarly, if you take x square LCM, 1x get cancelled, you will get one more x on numerator. X by x square plus y square. So finally, we will get the answer if you multiply, cross multiply. So if you cross multiply, what you will get, ma? X into x, x square by this denominator you will get as it is x square plus y square root x square plus y square plus, here you are having minus into minus plus, y square by x square plus y square root x square plus y square. Okay, finally, if you take this one as LCM, x square plus y square get cancelled. If x square plus y square get cancelled, what is remaining you are having? 1 by root x square plus y square. X square plus y square, x square plus y square get cancelled. If you take LCM, x square plus y square root x square plus y square, you will get plus y square. X square plus y square, x square plus y square get cancelled. What remaining? 1 by root x square plus y square. 1 by root x square plus y square means 1 by r. So now multiply these two. R into 1 by r. What you will get? Final answer. Dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y equal to r into 1 by r. 1. Clear, ma? Any doubts here? So this is a C type problem, ma? Next one, we need to show that Jacobian and its inverse Jacobian product is 1, like previous problem, same one, ma. So we need to prove Jacobian and its inverse Jacobian value product is 1. For that, x we need to write clearly u into v, uv, y will be uv only. Okay, now we need to find Jacobian. Here Jacobian is direct process. Direct process is this one. Dou of xy by dou of uv. What is formula, ma? Dou x by dou u, dou x by dou v. Dou y by dou u, dou y by dou v. So dou x by dou u, differentiate x with respect to u. Differentiation of u is 1. 1 minus v. Differentiate x with respect to v. Differentiation of v1, you don't have v here, 0 minus u. Dou y by dou u. Differentiation of u is 1, you will get v. Dou y by dou v. Differentiation of v is 1, you will get u. Now cross multiply. AD minus BC. u into 1 minus v. Here you will have minus, one more minus, plus uv. Now what you will get? U minus uv plus uv get cancelled. You will get u, ma. uv is first one answer. Clear? Next we need to prove the j dash value is 1 by u, so that j into j dash will be 1. That means to evaluate j dash, that means reverse this one. Dou of uv by dou of xy. So for that you need to rearrange the given functions in such a way that u in terms of xy, v in terms of xy. So for that what I am doing here, x equal to u minus uv. From this, what is u, ma? U equal to x plus uv. What is uv? uv is y. So u equal to x plus y. So u is x plus y. Now we need to find v like that. So we all know that y equal to uv. From this, what is v? Y by u. What is u, ma? What is u? U is x plus y. Y by x plus y. So using these two, we need to evaluate inverse Jacobian. This value we need to evaluate. Dou of uv by dou of xy. Simply I said how to write the formula. Ux, differentiation of u with respect to x. Uy, differentiation of u with respect to y. Vx, vy. So that's what I am going to find here. ux, differentiate u with respect to x, differentiation of x 1. Differentiate u with respect to y, differentiation of y is 1. Next, differentiate y with respect to x, vx. You don't have x in the numerator, no need to apply u by v. You don't have x in the numerator, so treat this one as constant. Differentiation of 1 by x minus 1 by x square. So you will get here minus 1 by x plus y whole square. Minus 1 by x plus y whole square. Next, differentiate this one with respect to y. To differentiate with respect to y, you are having in the numerator y, in the denominator y. So u by v rule we need to apply. That means like this: x plus y into differentiation of y1 minus y into differentiation of x plus y1 by x plus y whole square. Simplify this one, 1 minus y by x plus y whole square. Here plus y minus y get cancelled. What you will have? X by x plus y whole square. This is it. Plus y minus y cancel x by. Now AD minus BC. X by x plus y whole square. Here minus, you will get minus in the formula, plus y by x plus y whole square. Finally take x plus y whole square LCM. Numerator you will get x plus y. So 1x plus y will cancel. What you will have? 1 by x plus y. What is x plus y, ma? X plus y is u. So 1 by u. Now j into j dash. J value u, j dash value 1 by u. What you will get, ma? 1 by 1. U into 1 by u get cancelled. Like this we are going to solve one more problem on Jacobian, ma. If u equal to, next one, if u equal to y square by x, v equal to x square by y, then find dou of uv by dou of x comma y. Then find dou of uv by dou of x comma y. So here dou of uv by dou of x comma y equal to, so general, that formula, simple formula, what I said, ux uy vx vy. U differentiation of x, you need to differentiate u with respect to x. So here y square constant, partial differentiation, differentiation of 1 by x, differentiation of 1 by x minus 1 by x square. That's why what you will get, minus y square by x square. Differentiation of 1 by x minus 1 by x square. So minus y square by x square. Next, differentiate u with respect to y. 1 by x constant. 1 by x constant. Differentiate y square only. What is differentiation of y square? 2y by x. Similarly, differentiate v with respect to x. Differentiation of x square, 2x. Differentiation of x square, 2x by y. Now, keeping x square constant, differentiate y with respect to y. Differentiation of 1 by y minus 1 by y square. X square constant. That's why minus x square by y square. Now multiply these two. What you will get? Minus y square by x square into minus x square by y square into minus AD minus BC. 2x by y into 2y by x. See here, y cancel, x cancel. So there you are having 4. 2y by x, 2x by y. Multiplication, y cancel, x cancel. Here, y square cancel, x square cancel. So what you are having? Minus into minus plus 1 minus 4. So minus 3 you will get as answer. 1 minus 4 minus 3. See here, this one with respect to x, minus 1 by x square minus y square by x square. Differentiate this one with respect to y. With respect to y, keeping x constant, 1 by x, differentiation of y square, 2y, right? X square by y. Differentiate this one with respect to x, 2x by y. Keeping x square constant, differentiate 1 by y, minus 1 by y square. Now multiply, minus into minus plus. So y square by x square by y square get cancelled. So plus 1. Here minus 2x by y, 2y by x. Y cancel, x cancel. 4 you will have. 1 minus 4 is minus 3. Are you clear, ma? Any doubts? Okay, ma. Next Jacobian problem. So we need to find Jacobian of uv with respect to xy. That means dou of uv by dou of x comma y we need to find. So this is the formula: dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Differentiate u with respect to x, ma. If you differentiate u with respect to x, differentiation of x is 1. You will have cos y. Differentiate u with respect to y. With respect to y, differentiation of cos y minus sin y. That means minus x sin y. Next, differentiate v with respect to x. Differentiation of sin x cos x. So y constant. Differentiation of sin x cos x. Y cos x. Differentiate v with respect to y. Differentiation of y is 1. So differentiation of sin x with respect to y constant. So keep sin x constant. Differentiation of y is 1. You will get sin x. Keep sin x constant because we are doing with respect to y. Now multiply cos y sin x. In the formula you will have minus. You are having one more minus here. Plus xy sin y cos x. That's all, man. We cannot simplify this one. Next problem. If u equal to 2x minus y by 2, v equal to y by 2, then find dou of u comma v by dou of x comma y. Then find dou of u comma v by dou of x comma y. Similar one like previous. Dou of u comma v by dou of x comma y equal to. You can write formula like that, or simple one is that ux, uy, vx, vy. Like this also we can write. So differentiate u with respect to x. U with respect to x. Differentiation of x 1. This becomes 0. Differentiation of x is 1. 2 by 2, 1. This becomes 0. Y becomes 0. So next, differentiate u with respect to y. Here you don't have y. This becomes 0. Differentiation of y 1. So what you will get? Minus 1 by 2. Next, differentiate v with respect to x. Do you have x ma here? No. So this becomes 0. Differentiate v with respect to y. Differentiate this one with respect to y. Here we need to find dou of u by. Differentiate y with respect to y. Differentiation of y 1. 1 by 2. AD minus BC. 1 into 1 by 2. 1 by 2. Here you will get 0. So finally you will get 1 by 2 only. Clear, ma? So functional dependence, ma. This is just like a Jacobian concept only. We can say given functions are functionally dependent. We can say UVW are functionally dependent. Functionally dependent. If they are functions of x, y, z, then their Jacobian becomes 0. Jacobian vanishes. If Jacobian of UVW with respect to x, y, z, if UVW are functions of x, y, z, then Jacobian of UVW with respect to x, y, z is 0. Then UVW are said to be functionally dependent. So if you get a problem like show that the functions are functionally dependent means you need to prove that Jacobian value is 0. We will discuss one problem so that you can understand. Show that, this is the question. Show that u equal to xy plus yz plus zx, v equal to x square plus y square plus z square, w equal to x plus y plus z are functionally dependent. Functionally dependent. And hence find functional relationship between them. Functional relationship. So I am going to show U, V, W are functionally dependent. For that, what we need to do, ma? Jacobian of U, V, W with respect to X, Y, Z, we need to prove 0. So, first, I am evaluating Jacobian. Dou of U, V, W by dou of X, Y, Z. What is its formula, ma? Ux, Uy, Uz, Vx, Vy, Vz, Wx, Wy, Wz. Very simply. Differentiate U with respect to X. So here X you are having, here you are X you are having. In this term, in the second term you don't have X. That means that becomes constant, differentiation of constant 0. So wherever you are having X, there you will get 1 because differentiation of X is 1. So differentiation of X is 1. Y. Here you are having X, 1, that becomes 1. Y plus Z. Differentiate with respect to Y. Wherever you will have Y, there you will get 1. Simply. If you don't have Y, that becomes 0. Very simple. X plus Z. Differentiate this one. Here Y by 1, X plus Z. Differentiate with respect to Z. That means wherever you will have Z, there you will get Z, 1. If you don't have Z, there that term becomes 0. So this term becomes 0 because we don't have Z. Here differentiation of Z is 1, differentiation of Z is 1. What you will have, ma? Y plus X. Clear? Now differentiate V with respect to X and Y and Z. With respect to X, differentiation of X square to X. In the remaining two terms you don't have X, they are constant, differentiation of constant 0. Now differentiate this second term, differentiation of Y square to Y. Differentiation of Z square to Z. Only Z. While differentiating with respect to Z, differentiate only Z. While differentiating with respect to X, only differentiate X terms. While differentiating with respect to Y, differentiate Y only. Now, differentiate W with respect to X, Y, Z. Differentiation of X, 1. Remaining two terms becomes 0. Differentiation of Y, 0. Differentiation of Z, 0. Separate terms. That's why. So here 1, 1. Differentiation of Y, 1. Differentiation of Z, 1. Now, you need to prove that its determinant is 0. Then, the functions will be functionally dependent. For that, I am using one property of determinant. What that property says? The determinant of one matrix will be 0 if any two rows are identical. Any two rows are equal, then we can easily show that its determinant is 0. Otherwise, if you want, you can find that directly, plus, minus, plus, direct that method, you know. Like that also, if you find, you will get 0 only. But this is easy way, by applying one row operation, simply. So what I am saying, take 2 common from the second row. If you take 2 common from the second row, what you will have? Y plus Z, X plus Z, Y plus X. Second row you will have X, Y, Z, 1, 1, 1. Now add R1 and R2. What you will get? If you add this row to this row, X plus Y plus Z. Here also X plus Y plus Z. Here also X plus Y plus Z. Already YZ is there. If you add X plus YZ, X plus Y plus Z. Already XZ is there. If you add Y, X plus Y plus Z you will get. Already Y plus X is there. If you add Z, X plus Y plus Z. Then if you take X plus Y plus Z common, you will get first row 1, 1, 1, last row 1, 1, 1. Two rows are identical, then we can easily show its det is 0. That process I am applying now. R1 implies R1 plus R2. Then what happens? X plus Y plus Z you will get here. Here also same. Here also same. Then X, Y, Z, 1, 1, 1. Now from the first row you can take X plus Y plus Z common from the first row. So 1, 1, 1. X, Y, Z, 1, 1, 1. Two rows are identical. Whenever two rows are identical, its determinant becomes 0. That means 2 into X plus Y plus Z into 0. Because two rows are identical. That's why it's det 0. So totally Jacobian 0. What it means? Therefore, U, V, W are functionally dependent. Functionally dependent. Now, we need to find functional relationship. To find functional relationship, for 1, 1 problem, 1, 1 relation you will get. Functional relationship means how u, v, w are related with each other. For that I am using one famous formula in algebra, w square, that is a plus b plus c whole square. A plus b plus c whole square we know, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. That formula if you use, you will get the functional relationship very easily. W square equal to x plus y plus z whole square. Expand that formula which I said just now. X square plus y square plus z square. Instead of writing every time 2, 2, 2, I am taking 2 common. 2ab, 2bc, 2ca. I am taking in that 2 common. xy plus yz plus z. So what is x square plus y square plus z square ma? X square plus y square plus z square is v. So v plus 2 xy plus yz plus zx is u. 2u. This is functional relationship. Clear ma? Like this one can easily show given functions are functionally dependent. So next problem on functional dependence. We need to prove u and v are functionally dependent. For that, we need to evaluate dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y, so that one can easily evaluate its Jacobian. For that, I am writing u first now. X plus y by 1 minus xy. First I am evaluating Jacobian. Dou u by dou x. To evaluate Jacobian, I am evaluating what are the terms we will have in Jacobian, the terms separately. Dou u by dou x. Because you are having x in numerator, x in denominator, we need to use u by v rule. What is u by v rule? You all know what is u by v ma? Again I am writing u by v is vu dash minus ub dash by v square. This is formula. So using that formula I am going to evaluate dou u by dou x. 1 minus xy into, differentiate this one ma with respect to x. While differentiating with respect to x, keep y as constant. Differentiation of y is 0. So differentiation of y 0, differentiation of x is 1. Next, minus u is x plus y. X plus y into, differentiate this one with respect to x. While differentiating with respect to x, y constant. So you will get minus y only. Because differentiation of constant 0 by v square. V is 1 minus xy whole square. Now multiply numerator ma. 1 minus xy minus into minus plus xy plus y square. So minus into minus plus, you need to multiply this term with y by 1 minus xy whole square. Minus xy plus xy get cancelled. So what remaining you are having, that will be dou u by dou x. 1 plus y square by 1 minus xy whole square. 1 plus y square by 1 minus xy whole square, dou u by dou x. Similarly, we need to evaluate dou u by dou y. Dou u by dou y. Again here in the numerator you are having y, in the denominator you are having y. That means again you need to apply this formula, but with respect to y now. In the previous case with respect to x. For that, vu dash 1 minus xy into numerator differentiation. In general, while differentiating with respect to y, keep x as constant, this becomes 0. Differentiation of constant 0. Differentiation of y 1. Minus x plus y into, now with respect to y, right? With respect to y, x will be constant. Differentiation of y is 1. Differentiation of constant 0. Then what you will get? Minus x you will get. Differentiation of y becomes 1. Now the denominator square. V square. Now numerator you can multiply ma. If you multiply numerator 1 minus xy. Minus into minus plus. Multiply with x. Plus x into x. X square. X into y. Xy. By 1 minus xy whole square. Here plus xy minus xy get cancelled. What is dou u by dou y you are having? 1 plus x square by 1 minus xy whole square. This is dou u by dou y. Similarly, we need to differentiate v also. What is v actually? V is tan inverse x plus tan inverse y. That is v given. Now find dou v by dou x and dou v by dou y. We all know that differentiation of tan inverse x is 1 by 1 plus x square. Like that, dou v by dou x, you will get 1 by 1 plus x square, y constant. Next, dou v by dou y is 1 by 1 plus y square. Now you can find Jacobian easily. Dou of uv by dou of x comma y equal to dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. What is dou u by dou x? Dou u by dou x is 1 plus y square by 1 plus y square by 1 minus xy whole square. Dou u by dou y, 1 plus x square by 1 minus xy whole square. Now, dou v by dou x here you are having 1 by 1 plus x square, dou v by dou y 1 by 1 plus y square. Now multiply these two marks. What happens? 1 plus y square by 1 minus xy whole square into this one. 1 by 1 plus y square minus these two you need to multiply, AD minus BC. 1 plus x square by 1 minus xy whole square into 1 by 1 plus x square. 1 plus x square, 1 plus x square cancel. 1 plus y square, 1 plus y square cancel. What remaining you are having? 1 by 1 minus xy whole square. Here also 1 by 1 minus xy whole square. If we subtract two similar terms, two equal terms, 1 minus 1 0, 2 minus 2 0, like that, here 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square. What you will get? 0. Then what you can say about uv? If Jacobian of uv with respect to xy is 0, then uv are functionally dependent. That's what we need to prove. Functionally dependent means we need to prove Jacobian is 0. Over. Now we need to find functional relationship. Functional relationship, here itself from the question you can understand. Tan inverse x plus tan inverse y. There is a formula. What is tan inverse x plus tan inverse y? Tan inverse x plus tan inverse y. In inverse trigonometry there is a formula. What is that? Tan inverse of x plus y by 1 minus xy. That is formula for tan inverse a plus tan inverse b. The same formula I written. Tan inverse x plus tan inverse y. Tan inverse of x plus y by 1 minus xy. What is x plus y by 1 minus xy? X plus y by 1 minus xy is u. Then tan inverse, this can be written as u. So v equal to tan inverse u is functional relationship between u and v. That's what we need to find. Functional relationship. Functional relationship is this one. That is derived from inverse trigonometric formula. Tan inverse a plus tan inverse b is tan inverse of a plus b by 1 minus tan a into tan b. The same formula I apply. Are you clear now? Now we need to verify whether u, v, w are functionally dependent. If they are functionally dependent, we need to find functional relationship between them. For that directly we can evaluate Jacobian. If we can show Jacobian value is 0, then u, v, w are functionally dependent. What is u, v, w? U is 2x minus y plus 3z. V is 2x minus y minus z. W is 2x minus y plus z. Now I am going to find Jacobian directly. Dou of u, v, w by dou of x, y, z. There is easy way to write this Jacobian formula. Ux, uy, uz, vx, vy, vz, wx, wy, wz. Like this, you can easily write Jacobian formula instead of writing like dou u by dou x, dou u by dou y, dou u by dou z, like that, or like this also you can write. ux means differentiate u with respect to x. While differentiating u with respect to x, keep yz constant. Don't differentiate yz. So in the first term you are having x, differentiation of x is 1. So what you will get? 2. In the second and third term you don't have x, so the two terms become 0. Next, differentiate u with respect to y. So to differentiate u with respect to y partially, again same rule like x. Differentiate y terms only. Don't differentiate xz. In the first term you don't have y. In the last term you don't have y. So these two terms becomes 0. Differentiation of y is 1. You will get minus 1. Now differentiate u with respect to z. So while differentiating with respect to z, don't differentiate xy. Don't differentiate these two. If you differentiate also, the two terms becomes 0. Now differentiate this one. Differentiation of z1, what remaining? 3. Like that, you need to differentiate v. Vx, differentiation of v with respect to x. Differentiation of x1, so what you will have? 2. Don't differentiate yz. Now differentiate v with respect to y. Differentiate y only. Differentiation of y1, minus 1. Differentiate v with respect to z, that means differentiate z terms only. Differentiation of z1, minus 1. Now differentiate w with respect to x. Differentiate x only. Differentiation of x1, 2. Differentiate y with respect to y. Differentiate y only. Differentiation of y1, minus 1. Differentiation of z1. Now we need to find determinant of this matrix. If that is 0, then Jacobian is, then UVW are functionally dependent. Now I am going to find det for this, plus minus plus. Plus 2 into 2 corresponding column row eliminated. Then what happens? Minus 1, AD minus BC. Minus 1, minus into minus plus. Minus 1, minus 1. Minus 1, in between you will have minus, minus into minus plus. Next, minus into minus, plus 1 into second column first row eliminated. Second column first row, 2 into 1, 2, minus 3 2 jar. Second column first row eliminated, 2 1 jar 2, minus 1 into 2, minus 2, already you are having minus, minus into minus plus. Plus 3 into 3 corresponding column, last column, first row eliminated. 2 into minus 1, minus 2. In between you will have minus in the formula. Again one more minus, minus into minus plus. 2 1 jar 2. So see here one. What you will get? So 2 into minus 1 into minus 1 minus 1. Add these two. Minus 1 minus 1 minus 2. So minus 2 into 2 minus 4. Plus 2 plus 2. 4. Minus 2 plus 2 get cancelled, that becomes 0. 3 into 0, 0. Again, minus 4 plus 4 also cancel. Finally, what you will get? 0. So, then what happens? UVW are functionally dependent. UVW are functionally dependent. If UVW are functionally dependent, here see, are functionally dependent, and if so, if they are functionally dependent, find the relation between them. We need to find functional relationship between them. I said this will be exist in any way. For that, what we need to do, if you add any two, you may get third one. If you add all three, you may get 0. If you subtract one from another, you may get third one, like that. So now I am trying here by adding u and v. There is a chance of getting w. So u and v, what is u ma? 2x minus y plus 3z. V, 2x minus y minus z. So plus 2x plus 2x plus 4x minus y minus 2y plus 3z minus z, 3z minus z, 2z. Subtract 1z from 3z's. So now you can take 2 common here. If you take 2 common, because this is 2 2z, this is 2 1z, this is 2 1z. If you take 2 common, what happens? 2 2z 4, you will get 1 2, we will have one more 2, 2x, 2 common, minus y, 2 common, plus z. So see here very clearly, 2 into, what is 2x minus y plus z? 2x minus y plus z is w. So in that place we can write W. This is functional relationship between U, V, W. U plus V equal to 2W. Are you clear, ma?